For this problem, we want to sketch a graph by first making a table of values. Making a table of values means we want to choose some x values, plug them into our function, and get out y values, which will then graph to get a picture of our function. So let's say we choose the x values -5, -4, 0, 1, and 5. It doesn't matter what x values you pick. However, notice that we've restricted our x values between -5 and 5, so we just have to make sure that the numbers we pick stay within that range. Now we can plug each of our x values into f of x and get a y value. So for -5, we have -5 plus 5 is equal to 10. For -4, we have -4 plus 5 is equal to +9. For 0, we have -0 plus 5 is equal to +5. For +1, we have -1 plus 5 is equal to +4. And for +5, we have -5 plus 5 is equal to 0. So let's go ahead and graph these points. For -5, 10, we'll go to the left -5 and up 10. For -4, 9, we'll go to the left 4 and up 9. For 0, 5, we'll go over 0 and up 5, which would put us about right there. For 1, 4, we'd go over 1 and up 4. And finally, for 5, 0, we would go over 5 and up 0. So now that we have our points graphed, we simply want to connect them with as straight of a line as we can. Of course, you guys are on WebAssign, so your line graphing tool will allow you to do that. So that is how we sketch the graph by making a table of values. So now let's try to sketch a graph of the following functions. So notice now we're looking at piecewise functions, which means you have different equations for different values of x. So for our first piecewise function, we have 2x plus 5 if x is less than -1, and we have 5 minus x if x is greater than or equal to -1. So what I like to do for these is break it up in parts and graph one piece of the function at a time. So for the line 2x plus 5, the first thing we need to do is graph the y-intercept, which would be +5. So we'll put a dot at +5. And then our slope is 2. So we're just going to count a slope of 2. So we'll go down 2 and over 1, down 2 and over 1. And so our first line would look something like this. So once we've drawn this line, we want to restrict the line to the x values that it has. So this one has x is less than -1. So what this means is we're going to erase the portion of the line where the x values are greater than -1. So we're left with this. And since our inequality is strictly less than, we're going to make sure we have an open circle there. So open circles are if your inequality does not have an equal sign. Closed circles are if your inequality does have an equal sign. So this line that I have right here is the first branch of our piecewise function. Now for the second branch, we have the line 5 minus x. So first we graph the y-intercept at 5, and then we count a slope of -1. So we'll go down 1 and to the right 1. And maybe I'll put a point above because I know I need to hit the x value -1. So now I've got this line on this side doing this. And that would be the second branch of my piecewise function. And so we're done with the entire function at that point. So let's try one more example of a piecewise function. This time I have 3 branches. So we have -2 if x is less than -2, x if x is between -2 and 2, and +2 if x is greater than 2. So once again, let me draw my axes here. And I'll mark some values on each axis. Okay, so let's start with the branch -2. So when you see y is equal to a number, this means that we have a horizontal line at that specific y value. So y equals -2 would be down here. Okay, but notice that my x values are only less than -2. So what this means is I only want the portion of the line that is less than -2. So I'm going to erase every part of the line that is not like that. And also, since my inequality was strict, I need to make sure that I have an open circle at -2. So I'm done with the first branch. For the second branch, I have the line y is equal to x between the x values of -2 and 2. So to graph the line y is equal to x, we know our y-intercept is 0 and our slope is 1. So we're just going to count a slope of 1. And that would put us right here. I'm going to have closed circles on both ends because my inequalities have equal signs. And so what that's going to do is actually fill in this circle that we originally had open on the first branch. So now I'm done with the second branch. And finally, I need to do the third branch. So we have y is equal to 2 if x is greater than 2. So I'm going to have a horizontal line at 2, and I want to start at the x value of 2. Well, that's going to be this shaded circle that we had from the second branch, and I'm just going to draw a horizontal line from there. So that takes care of our third branch, and so now that is the graph of your piecewise function.